Okay, so today's lesson is going to be on using these sum and difference identities. But before we do that, I want you to take a minute in your groups and discuss the patterns that you notice in those four equations so that it'll make it easier for you to remember which one is which, and rather than memorizing four different formulas, maybe you can narrow it down to just two. And so discuss in your groups what patterns you notice in all four of those sum and difference identities. Okay, quiet down please. All right, so Peyton, what's one thing that your group noticed, a pattern that you recognized?
That, like, if you memorize just the top, so you, like, the sine a plus b and then the cosine a plus b, then the signs are just flipped for the one underneath it, so the positive becomes the subtraction.
Okay, that's true. So the signs both follow the same pattern. For sines, it always goes sine, cosine, cosine, sine, and for cosine, it goes cosine, cosine, sine, sine. Okay, so that pattern is definitely there. One thing that helps some students remember that is they say sine.
It's frozen.
They say sine makes a sandwich. You've got the cosine in the middle, that's the meat. You've got the sines on the outside, that's the bread. So sine makes a sandwich. If that helps you remember that sine has the sines on the outside and the cosines on the inside, then that's great. So sine makes a sandwich. Okay? What other patterns did you notice? Victor?
Cosine will always be the same. Like, they'll always be paired with the same
Cosine addition subtraction is going to be flipped. Like if it's cosine a plus b, then it's cosine minus sine.
Okay, so you're saying the sign in the middle gets flipped for cosine but not for sine? Okay?
Yeah.
So this sign stays the same when we're doing sine. So sine has the same sign. Sine has the same sign.
Oh, aren't you worried? Nice.
You can make a number with that.
So cosine has what?
Different sign. Opposite sign.
Has the counter sign. Sine has the same sign, cosine has the counter sign. S, S, C, C. Sine makes a sandwich.
Well, I always spelled sandwich differently.
What?
I've always spelled sandwich like sand and like a witch, you know, like W-H.
Oh, W-I-T-C-H?
Wait, is that how you're supposed to spell?
Yeah, isn't that weird?
That's how you
Oh,
spell sandwich,
wow.
yes.
I always spelled it like sand, like witches, like Halloween
Wow.
witches.
Okay.
Oh,
So now we're going to do some examples on how to use those identities,
Yeah.
okay? And so those identities will help us find exact values for sine, cosine, and tangent for some angles that we haven't worked with before. So up until now, using the unit circle, we've only done angles like 30, 60, 90, 45, and multiples of those, okay? But 15 is not a multiple of 30, and we don't have a special right triangle for 15 degrees. That's why we were able to do all those other ones, because we had 30, 60, 90 triangles and 45, 45, 90 triangles. But 15, we can't get 15 using a special right triangle, but we can write 15 as a difference of two angles. What two angles can we subtract to get 15?
45 and 30.
Okay, so this is the same as the cosine of 45 minus 30. So now we're going to use
Oh my god. It's like we're connected.
this one. We're going to use the cosine, the difference, the cosine difference equation, and so that's going to be equal to cosine 45, cosine 30, and then is it a plus or a minus?
Plus.
It's a plus because it's the opposite of that. Cosine has the counter sign. And then it's going to be sine 45, sine 30. Okay? And cosine of 45, what's that? Root 2 over 2. Cosine of 30?
1 over
Root 3 over 2.
Unit circle tattooed on my wrist.
Sine of 45? Root 2 over 2. Sine of 30?
What if I told you?
1 over
What if I told Teddy that I just that was what I wanted?
Sine of 30 is 1/2. If you don't remember those, you need to brush up on your unit circle.
Oh, we have.
Get a tattoo right here.
You can't do these if you don't know the unit circle.
Can we have it?
I want to use that semi-permanent ink, you know, that lasts for like 3 years.
The one that I asked you guys to memorize, if you can memorize that the sine of 30 is 1/2, you can visualize that. Sine of 30 is 1/2. The short leg of the right triangle is 1/2. Then that will help you with the rest of them, because we said if sine is 1/2, then cosine, what number always goes with 1/2? Root 3 over 2. Okay? And so then when you have a 60-degree reference angle, those just switch places. So it looks like some of you need to review those common angles on the unit circle. Okay? So let's go ahead and do B. This one is in radians, but we can still do the same thing. Okay? So 7 pi over 12. We're used to working with things like pi over 6 and pi over 4 and pi over 3. So how can I make 7/12 using 6ths and 3rds and 4ths? What are two numbers that add up to 7?
6
3 and 4.
3 and 4. So those will work. So we can do sine of 3 pi over 4 plus, 3 pi over 12 is what I meant. So 3 pi over 12 and 4 pi over 12, those add up to 7 pi over 12, right? And so now we can simplify those. That's just pi over 4, and that is just pi over 3. And so now we're ready to use the sum equation for sine, and that's going to make a sine sandwich. That's sine pi over 4 cosine pi over 3, and is it going to be a plus or a minus? Plus, because sine has the same sign. Cosine pi over 4 sine pi over 3.
So for A, do you just leave the answer as
No, actually, we should have finished that. This would be root 6 over 2 plus root 2 over 4. Sorry, this should be root 6 over 4, root 2 over 4. And then, since they have the same denominator, we can say that's root 6 plus root 2 over 4. And then that would be simplified. That is simplified. Okay, so thanks for reminding me of that. We got sidetracked with the unit circle, and I didn't come back to finish that. Okay? So, sine of pi over 4. The 45-degree angle should be easy, guys. Root 2 over 2. Sine and cosine of pi over 4 is root 2 over 2. Those are the easy ones. Those are the 45, 45, 90s. They're both the same. Sine and cosine are both root 2 over 2. Okay, cosine of pi over 3. That's cosine of 60, right? That's 1/2. Cosine of pi over 4? Root 2 over 2. Sine of pi over 3, which is sine of 60?
Is that Kim possible?
Root 3 over 2. What's Kim possible?
Like,
I didn't hear that.
Oh, there's like someone's wrong.
Dude, it's so close.
And so then that is root 2 plus root 6 over 4. They're the same.
That's true.
Okay. Go ahead and try C and D. That's why we're doing this one, yeah. That's why we're doing this one that
Yeah, I
way.
know. I appreciate it.
Okay, so as we mentioned, there are a lot of options for breaking up 195. So 135 plus 60 is one possible way to do that. So then I would do sine of 135 cosine 60 plus cosine 135 sine 60. And sine of 135, if we picture the unit circle, 135 is over here. It's got a 45-degree reference angle. And so we know at 45 degrees, both coordinates have a root 2 over 2 in them. The only difference is in quadrant 2, the cosine is negative. So it's going to be negative root 2 over 2, positive root 2 over 2. So the sine of 135 is positive root 2 over 2. And then cosine of 60, we know the cosine of 30 is root 3 over 2, so the cosine of 60 must be 1/2. And then cosine of 135, that's right up here in our diagram, and that is negative root 2 over 2. And the sine of 60 is root 3 over 2. And so then when we multiply those and add, we get root 2 minus root 6 all over 4. 2 times 2 is 4. Okay, so that's our final answer for that one. You may have gotten negative root 6 plus root 2. That's the same thing. Okay? And then for D, let's see, Krista, how can you split up 5 pi over 12?
2 pi over 12 and 3 pi over 12.
Okay, that's easy. So 2 pi over 12 plus 3 pi over 12 is equal to 5 pi over 12. And 2 pi over 12 reduces to pi over 6, which is the same as 30 degrees, so we know how to work with 30 degrees. 3 pi over 12 reduces to pi over 4, which we also know. And so then this is going to be cosine pi over 6, cosine pi over 4, minus sine of pi over 6, sine of pi over 4. And cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. And sine of pi over 4 is root 2 over 2. So then we end up with root 6 minus root 2 over 4. Okay, questions? Okay, now for tangent, for part E, I'll do this one with you. For tangent, there is, if you look in some textbooks, and maybe even in this one, I'm not sure, but they have a sum and difference formula for tangent, but that's just one more thing to memorize, and it's easier just to remember what you already know, which is tangent is just sine over cosine. And so we can, and how would we break down 165? 135 plus 30 would work. 120 plus 45. Okay, that would work also. Okay. What do you want to use, Haley?
Yeah, Haley, what do you want to use?
What? 120 plus 45. Okay? And so then we're going to write that as sine over cosine. So sine of 120 plus 45 over cosine of 120 plus 45. And so on top we're going to have sine 120 cosine 45 plus cosine 120 sine 45. In the bottom, we'll have cosine, cosine, minus sine, sine. Okay, for 120 degrees, what's the reference angle? In other words, what's the shortest path to the x-axis? If you're at 120 degrees, if this is 120, what's the shortest path to the x-axis? How many degrees?
60.
60. 180 minus 120 is 60. So it's a 60-degree reference angle, so you can draw it more like this. This is 120, so this is a 60-degree reference angle. And so we know that sine of 30 is 1/2. That's the one that you, if you can remember that one, if you can remember the sine of 30 is 1/2, then the sine of 60 can't be 1/2. It must be root 3 over 2, because that's the one that goes with it. But you're right, it's negative because, no, it's still positive because the y value in quadrant 2 is positive, so this would be negative 1/2 positive root 3 over 2. And so the sine is positive root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 120, negative 1/2 from our diagram. And sine of 45, root 2 over 2. Then in the bottom, we have cosine of 120, which we have in our diagram, negative 1/2. Cosine of 45, sine of 120. See how important it is to draw this, because then we can constantly look at it for every number that we're filling in. Okay? And now up on top we have root 6 minus root 2 over 4. And in the bottom we have negative root 2 minus root 6 over 4. If we flip the denominator and multiply, the 4's will cancel. We'll just end up with root 6 minus root 2 over negative root 2 minus root 6. Or you could also do this, root 6 minus root 2, put a negative out in front, and then it's root 2 plus root 6 in the bottom. So this is fine. This is also the same.
Wouldn't the 2's cancel out?
No, those are not common factors. Those are terms. We can't cancel terms. You can only cancel factors. So it would not be okay to cancel any of those. You can't cancel things that are being added and subtracted. You can only cancel things that are being multiplied. So for example, if you had root 2 times root 6 over root 2 times 5 or something like that, you could cancel those. That's multiplication. But if you're adding, if we change these to plus signs, you can no longer cancel them. Okay? Any other questions? Okay. Try the last one. Tangent of 23 pi over 12. And so on the unit circle, so the way I broke it up was 3 pi over 12 plus 20 pi over 12, and 3 pi over 12 reduced to pi over 4, 20 pi over 12 reduced to 5 pi over 3, and we know how to do both of those. And 5 pi over 3 is right here. I broke the circle and I broke the half circles into thirds because we know pi is half a circle, so cutting that into thirds, we have 5 thirds of the circle, and the 5 thirds of each half. And so that's going to give us a 60-degree reference angle. And so this is 1/2, and this is root 3 over 2. And so that gave us the coordinates of the point 1/2, comma, negative root 3 over 2. And then you can see how I filled in the rest of the values there. And in the end ended up with root 2 minus root 6 over root 2 plus root 6. Now if you did a different pairing of the angles, let's say you did, let's see, what was another combination that some of you did? instead of 3 pi over 12 and 20 pi over 12. What else did some of the groups try? What did you do, Patrick?
15 pi over 12 plus 8 pi over 12.
Okay, so that would work as well. All the parts are going to be different, but in the end you should get the same expression if you do everything correctly. Okay? So if you did a different angle pairing and you don't know why it didn't work, then you can call me over and I'll see if I can help you fix it. You can also check these on the graphing calculator pretty easily. So if you work a problem out and you're not sure if the final answer is right, what you can do is first check and make sure your calculator's in radian mode. Everyone do this with me right now. So go to mode, make sure you're in radian mode. So I'm going to change mine to radians, and then quit, and I'm going to first type in tangent of 23 pi divided by 12. So 23 pi over 12, we know the answer should turn out to be negative 0.2679. And so now I take the answer that I got, the root 2 minus root 6 over root 2 plus root 6, and so I'll try that. Square root of 2 minus square root of 6 divided by, make sure you put both the numerator and denominator in parentheses, root 2 plus root 6. Enter, and we get the same decimal, confirming that we must have done something right. Okay, so that's it for that lesson on using the sum and difference equations for sine and cosine.